Hello, hello. Thanks for joining me. We're going to use some applications of this trigonometry and see how things are used in real life. A lot of surveyors, for instance, soil consultants and FCA, they are land surveyors, and so they use a lot of these techniques on the daily. So it's good to get an idea that this isn't just random stuff, but that God designed it to be useful and to be helpful and so on. So here we go. We're going to learn the definition of an angle of elevation versus what an angle of depression is, and then use them to solve for missing pieces, missing measures. An angle of elevation is used when we're talking about spotting from the ground to something above you. This angle right here is called the angle of elevation. This is called the angle of elevation. So it's between the ground and the line of sight. Okay? The angle is the angle that is made with the ground. Okay? Notice how in both cases, like here is the angle of elevation, here is the angle of elevation. Notice how a right angle is formed here. Okay? That's useful for these trig functions. Okay? Angles of elevation and angles of depression, they form right triangles with the thing being spotted. All right? So let's say we have a golfer who is standing at the tee and looking up to the green on a hill. So the green is above him, higher than him, and he's trying to figure out the distance between him and the tee. If the tee is 36 yards, the tee where he stands is 36 yards lower than the green. Here's the green. That's where he wants to get his ball to. And the angle of elevation from the tee to the hole is 12 degrees. Find the distance from the tee to the hole. So in terms of the right triangle, distance from one spot to another spot, that's going to be your hypotenuse. When you read horizontal distance, that's going to be like from here to here. But what they're looking for is this hypotenuse distance. All right. So we have an angle of elevation of 12 degrees. We have a side opposite, and we're looking for the hypotenuse. So which trig function should we use? Sine, because I have an opposite and a hypotenuse. So the sine of 12 degrees has to equal 36 over x. Then I'm back to just like we did yesterday, solving for that missing side. So x times the sine of 12 has to equal 36, and x is going to equal 36 divided by the sine of 12. And for that, we get 173 yards. That's a par 3. $173 yards. The recommended angle of elevation. So that's a keyword, angle of elevation. We're going to be looking up. So we're looking from the ground to something above us is 75 degrees. Okay. at what height on a building does a 21-foot ladder? Okay, 21-foot ladder. So we're going to lay that up against the building. So this is our hypotenuse. Okay. If the recommended angle of elevation is used, so that's 75, right? And we want to know how far this is. What's this distance from here to here? That's x. We want to know what x is. So if we were just to draw the triangle, we would have x, we would have 21, because that's the length of our ladder, and we would have 75. So now, which trig function do we want to use? We have opposite and a hypotenuse. So we would use the sine of 75 degrees has to equal x over the hypotenuse, which is 21. So to solve for x, I multiply both sides by 21. And I get it has to be 20.3 feet up the building. So this has to be 20.3 feet. All right, same kind of problem. We even use the same recommended angle of elevation. How far away should the 21-foot ladder be placed from the base of the building, which might be an even better question to ask to create this recommended angle of elevation, because it's going to be a whole lot easier to measure out from the building. So here's the side of our building. Here's our ladder, all right? This is 75. This is 21. What's this distance? Right? Well, we're going to use the cosine because this is the adjacent over the hypotenuse. So the cosine of 75 degrees has to equal x over 21. I'm going to multiply both sides by 21. 21 times the cosine of 75. And we just plug that into our calculator like we've been doing. 21 times cosine 75. So that means it needs to be placed 5.4 feet from the base of the building. 5.4 feet equals x. So we want this distance here to be 5.4 feet. All right, now we're going to concentrate on angles of depression. Angles of depression are same type of thing, only they're created when someone is above, all right, and they're looking down. So it's created by, let me get my highlighter here, by the horizon, eye level, and then what they're spotting below it. Okay, here's your angle of depression between the horizon and then the line of sight down and something below it. Okay? All right. If the lighthouse is 150 feet tall, okay, and the angle of depression from the light to the ferry is 17 degrees. So where's our angle of depression? Here. Oh, crumbly. All right. So here is our angle of depression here, and we want it to be 17 degrees. Okay? The lighthouse is 150 feet tall. So that's this distance right here, from here to here. If this is 150 feet, then cool, and oddly enough and wonderful, this is 150 feet. Okay? Okay. Find the horizontal distance. We're not looking for how far the boat is from the lighthouse. We're looking for the horizontal distance between the boat and the lighthouse. So this is what we're looking for here. X. I don't know why I keep writing crummy for you. Okay, so what sides do we have? This is an adjacent side, and this is a side opposite. So which trig function should we use? Well, tangent, because we have opposite and adjacent. All right? So we have the tangent of 17 degrees has to equal 150 over x, and I want to solve for x. So I'm going to multiply both sides by x, and that gives me x times the tangent of 17 equals 150, and then I'm going to divide both sides by the tangent of 17. And I get a distance of x equals 490.6 feet. So that's this distance right here. How far away? All right. A roller coaster has an angle of depression of 87 degrees. Woo, that's steep. So we're here, we're at the top of the roller coaster, and we have an angle of depression of 87 degrees. So that's like almost straight down. Okay? And there is a vertical drop of 350 feet. Find the length of the hill. Find the length of the hill. So our vertical drop is 350. And we're looking for the length of the hill. All right. Well, there's a couple ways we can do this. If this is 350, then over here is also 350, right? This is going to be almost foot by foot. I'm going to start over and draw this different because I just think that that's so messy. Okay. I have this roller coaster coming up and dropping, right? And then my angle of depression, here's my line of sight. My angle of depression is 87 degrees. Okay? So what is the length of my hill? I have a vertical drop of 350. All right? So what's the length of my hill? I'm looking for this over here. And this angle is 87 degrees. So I have what? My hypotenuse, and this is my side opposite. So I'm going to use sine of 87 degrees is equal to 350 over x. So x is going to have to equal multiply both sides by x, divide by sine of 87. So I get 350 over the sine of 87. And that comes out to like 350. It actually has to be longer. So the thing is that you have to start these people higher than 350. Otherwise, you're going to crash into the ground. Whoops, sorry. 350 divided by sine of 87 equals 350.5 feet. Right? Okay, a hawk is in a 35-foot tree. If the angle of depression between the bird and the mouse is 35, so here's my angle of depression. Okay. Find the distance the mouse is from the base of the tree. Okay, so we're looking for this one right here, right? Because in this triangle, you just have to use this top one because we're talking about an angle of depression. Okay, so we need to find what the distance that the mouse is from the base of the tree. So we're looking from this one. We're looking at this right here. Okay, and how tall is the tree? Well, it's old. It's 35 feet. So what do I have? I have a side opposite, and I'm looking for a side adjacent. So I'm going to use the tangent. Tangent of 35 is equal to 35 over x. I'm going to solve for x, which means I multiply both sides by x. And then I divide both sides by the tangent of 35. Okay. So I have 35 divided by tangent of 35. And I get that that little mousie is right about 50 feet away from that hawk. Okay. So a lot of times, scoping systems that people attach to guns or bows or whatever, they'll be based on these trigonometric functions. All right. Now read this problem, because on the surface it looks like we just did it. But look at what it's asking. A hawk is in a 35-foot tree. The angle of depression between the bird and the mouse is 35 degrees. So again, same angle right here, right? Okay. Oh, find the distance between the hawk and the mouse. It's not asking for the distance between the base of the tree and the mouse. It's looking for the distance between the hawk and the mouse. This is the hypotenuse. Okay. So we know again that the tree is 35 feet. But now we're looking here. So which trig function would we use for that? Well, this is an opposite, and this is a hypotenuse. So I'm going to use sine. Sine of 35 degrees is equal to 35, my side opposite, over my hypotenuse, which is x. I'm going to solve for x, which means I multiply both sides by x, and then divide both sides by the sine of 35. Divided by sine of 35, and I get that hawk is actually 61 feet away. Okay. All right, that's it. We'll work on some of these. We'll work in class together. All right, have a good evening. Thanks again for watching.